Hey guys, welcome back from spring break. Today we're talking about remote sensing. This refers to a type of oceanography that's done from space. Believe it or not, we learn a lot about the ocean from leaving this planet and taking images with the satellite. I got a lot of great photographs and other maps from NOAA's website. That's where I got them for this. And remember NOAA, NOAA. It's like NASA, but for the ocean. It has a cute, watery pun, kind of like Noah's Ark. And you might Google NOAA when you try to complete the homework related to this PowerPoint. First, we're going to talk about weather. Now, every topic of investigation presented in this slide will relate to something on the homework. Weather is a really important subject. It's expensive. We try to predict it. And as you probably already know, we use satellites. Maybe you have seen radar images on the evening news talking about local weather. Well, we're going to get into that first. We can use any satellite to basically look at our ocean. By getting high above the planet, we can get way more information than having our nose right in the problem. And we can learn about other things too. We'll talk about temperature, color, coral reefs. Basically, we can communicate with people in different parts of the earth using the satellite as a go-between. There are some other things we can do that we'll be getting to. So, let's get to it. Sea surface temperature. Well, you all know about climate change. We will probably be talking about it more at the end of the semester. In general, knowing the temperature of the ocean surface tells us what's happening in the ocean. Why does this matter? Well, temperature changes influence animal behavior. These temperatures can affect the bleaching of corals. Bleaching is bad. Temperature of water creates weather. And a satellite image of the sea surface temperature can show us patterns of water circulation. If you Googled ocean currents for your last homework assignment, you probably saw maps of warm and cold currents. A lot of those are taken from satellite imagery. The Gulf Stream, for example, is a pretty famous warm current. Now, we use a couple different satellites to do this. And for this assignment, I'm not going to ask you to know the individual satellites. Sometimes they get retired. But just in general, some of them capture new data every day, and some have scientists put together maps, so they kind of do some of the thinking for us. There's more data than we can process sometimes. Satellites are pretty awesome. Now, another thing we look at with satellite imagery of the ocean is the color of the ocean. This bright green spot you see and red spot, that's what's known as a harmful algal bloom. It's too much algae, too much plant life in the ocean. This is a big problem in the Santa Monica Bay, not just in Alaska like in this picture, but here in California we worry about harmful algal blooms because they can contaminate shellfish like clams, they can kill fish, they can cause problems in human health, and they are often created by human endeavors. For example, the sewage treatment plant in El Segundo can elevate the temperature of the water, which creates a harmful algal bloom. Okay, this particular image is showing sea level change. Now, why does that matter? Why do we care about sea level? Well, when the sea level rises, every time we have a storm, more and more and more of the coastline can be damaged. Let me pull this down so you can see that scale better. And we don't want coastal damage. We also don't want native environments like wetlands, mangrove forests, for example, to be drowned and injured. We measure sea level all over the planet using satellites, and we measure long-term changes in sea level. So as ice melts up at the poles of the Earth, as you know, let's take this back to where it was, and you can see the poles of the Earth. That's a big problem because it makes sea level rise everywhere. Now, we don't worry about that too much in Los Angeles because we have pretty high elevation. But if you lived in a place with no plate tectonics, like Florida or New York City, especially the island of Manhattan, then sea level rise is a real existential threat. It could eventually put whole streets and neighborhoods underwater, displacing people, creating climate refugees, impacting the economy. That's why we measure this. Okay. Now, what about mapping? Sorry about that. Let me move this whole thing down. There you go. So how do we use a map made by a satellite? Or another way of saying this is, why is a satellite image of the ocean floor better than one we make by visiting the ocean floor? Well, this is my favorite one. It's pretty clever. Basically, because of gravity, if the ocean floor drops down, it has less mass. So, for example, a deep trench will result in less gravitational pull on the water above it. What I'm trying to say is that we look at tiny, tiny, tiny differences in sea level, and these tiny, tiny differences can tell us, oh, there must be a mountain under the water there with an extra gravitational pull, or maybe there's a big canyon down there with less gravitational pull. And everything you see in this beautiful image was calculated by computers on a satellite using tiny, tiny, tiny variations in sea level. And what we end up with is a highly detailed map. This particular map was made this way, and you can see the entire ring of fire on it, plate boundaries. It's quite beautiful. Also, ships have only mapped a tiny, tiny fraction of the seafloor, so we actually can get more done and in a more efficient way when we use a satellite. Okay, so let's talk about something that would grab your attention. Weather. Okay, so let's talk about weather. Now, I don't know what is going on. Sorry about that. This should make you feel like you're back in class when I have a PowerPoint problem. There's a real human behind this, right? So, weather. This is, of course, an image of a hurricane. Pretty scary. You are used to hurricanes happening on the East Coast and on the Gulf Coast, and that's because these are places with warmer water. California current is cold, so we don't typically get hurricanes. Bad news for you, good news for hurricanes. California's sea temperature is increasing, just like every place else, which means it's possible to see hurricanes here in your lifetime. When I was a student, we had hurricanes down at the tip of Baja California because there is warm water down there. And since I've been teaching, the hurricanes have come further and further north, chasing the warm water. So you may have heard of hurricane trails hitting San Diego. That's because these types of warm water storms are indeed moving north. You can think of the ocean as a giant HVAC system, just like the air conditioning heating system in a building. The ocean redistributes heat, and if there's more heat to distribute, a storm is a really efficient way to do that. So we use satellites for short-range weather forecasts and for long-term questions about general climate change. And to remind everybody, climate happens on a long time scale. Weather happens every day. When I say weather, I mean, what do you notice when you look out the window? When I say climate, I mean, what is the average of all that weather? Okay, and finally, I want to talk about tracking. This is particularly special to me because I lived in a town that used to track sea turtles when I lived in Mexico, in northern Mexico, during my graduate school years. And turtles are wonderful. They will swim from Mexico to Japan and then back. And some researchers from Mexico City would let me live on their land, very nice people, and sometimes I could help them with the turtles. They would put these GPS images on the turtle, and the turtle would swim to Japan, and sometimes a turtle would get caught in a net in Japan and accidentally drown. And the Japanese fishermen were very kind in noticing the GPS receiver, and they would always report these accidents so that we could still use the data. And what they found was that the turtles were crossing the ocean far quicker than anybody expected. They were using currents like freeways, and they were also following temperatures that they enjoy. So a turtle is kind of like a satellite. It kind of collects data for us in part of its life cycle. And by the way, if you've been paying attention to the news lately, as humans have disappeared from beaches, turtles have shown up in big crowds, especially in tourist beaches in Thailand and Florida. And they're laying eggs in nests and making good use of these empty beaches to sort of bulk up their populations. So that's kind of a positive news thing I wanted to share with you. So that's a very cursory introduction to satellite oceanography. I hope you learned something about the different types of subjects we study from space. Thanks.